Nick here from Murky Customs. I thought I'd take a moment, and I thought this was a good spot to bring everybody up to speed on where we're at, what we're doing, and for the latest build. What we're doing here is we're Rube Goldberging a bit of a contraption here. Basically, we're going to build a NAS with 38 USB 3 connected laptop 2.5-inch SATA drives. It's essentially these guys up here. And essentially what I've done is I got a line on a bunch of drives coming up for auction. And essentially I paid about $350 for a box of them. And most of them were actually still in their USB enclosures. Essentially there used to be a plastic plastic housing around this. This is kind of a generic enclosure, not made by Toshiba or Western Digital or Seagate or anything like that. These were just sort of in a gaudy plastic enclosure. What I've done is just taken the enclosure off, and then essentially what you're left with is a stock Toshiba hard drive that you can buy off of Newegg or wherever. These run about $55, $60 a piece, and a USB or a controller. This should look familiar. These controllers just connect right on, and this essentially just converts the power and data and all that fun stuff to use the 3.0 900 milliamp connectors. So all I've done is essentially taken the enclosures off and pulled out the hard drives, and then what I'm doing for this enclosure here, if you look, I've got a whole crap load of icy dock 3.5-inch bay hot swap trays. And you may ask, why do I have 38 of them and not a couple of the 6 bay or 8 bay drives? And then essentially what it boils down to is, because I want to be sort of a crazy lunatic and USB 3 connect all these drives to the system, I can't use bays that have more than one drive in them, because essentially on the back of it, and I'll show you what the back of this guy looks like here, you don't have the normal pinout or the standard pinout with the SATA power right next to the SATA connector, which means this USB connector won't fit on it. Most of them, there's crappily designed ones that have something similar, but most of the good ones, what they've done is just given you banks of SATA connectors, and then there's a Molex connector, or there's one or two power connectors off to the side. Which doesn't do me any good, because I need one of these connectors for every single drive. So after lots and lots of searching, what I've come across are these icy dock drives, and essentially these are hot swap bays that have a direct connector on the back. They also have on top of the hot swap, I was also looking to make sure I could get hard drive activity lights. So there's power lights that'll blink orange for data activity. And of course, on the back of it, the I/O lights, if I go ahead and access this drive, in a second here. Yeah. So we have our I/O activity lights in the back here, which this manufacturer's gone with blue, which I don't hate. And then of course, you'll have your actual hard drive activity lights up front, which the controller's intercepting in the back here. What's great about these icy dock drives is that they are just direct connect. So there's no vendor funny business. I've used icy dock a bunch of times in my normal business work and my forensic work. And icy dock just makes a great product. This happens to be an all metal enclosure. It's fantastically built. I'll go ahead and pop one of these guys out. Essentially, it's just a toolless drive bay. And so you can't complain. Well, you win some, you lose some. So yeah, I mean, these are great. I'm gonna go ahead and grab that guy again. It'll, it's gonna hold the drive in place. It's gonna act as a hard drive cooler with all the metal. And they've got strategic air vents all over these things. It's just really, really nicely made. These run about $35 a piece. 35 to 40 depending where you get it. They seem to be in that realm on Newegg and excuse me, the normal vendors. I happened to find them on sale at Walmart of all places when I was strategically looking for these things. Now, mind you, at 38, that's still setting me back $1,000, a little over $1,000, and that's a lot of damn money. But if I will say, if you're just looking to a really neat USB enclosure for something you would take, if you're looking for a mobile hard drive, these are a great option. They make a bunch of vendors will actually make just a connector, looks like this on the back end. It's all just one cable. So this black cable would just kind of come over and plug right in. And to easily convert this to a USB enclosure that you could take with you, which is a great option because it's nice, it's hard, it's metal, it's got a lock on the front, and your drives will last forever because you're not blocking the pins or anything like that, or your breather holes and all that fun stuff. So I do recommend this immensely if you're looking to do a mobile enclosure. Now, of course, what we're going to do is we're going to take a whole crap load of these and put them into an enclosure that we're building. So let me pan over here a second and look at this crappy schematic. There are fancier ones available, but I think this will get you the idea of essentially what's going on here. What we're going to do is essentially we're going to make this out of wood. And we're going to build, this is going to be a 30 by 30, and this is going to be a coffee table, essentially. So we're going to do a 30 by 30, and these bays are about 4 inches apiece, just over 4 inches. So that's what these are here. There's 14 aside, and then there's going to be another 5 here and 5 here, which is going to give us a total of 38. And then, of course, we're going to have the power supply and the motherboard in here. You may notice that there's spaces in between, and that's because I don't want to butt those up directly to each other, A, because it wouldn't look good, and B, because you need wiggle room for aesthetic purposes. In this case, I'm going to use fiberglass, because what this is going to have is underneath all this stuff, this is going to go down about 6 inches, just over 6 inches, and then there's a mesh tray that's going to be under there, and then I'm going to be running in between all of these. There's going to be fiberglass, as well as around the motherboard tray here. And what that does is the mesh tray is in place because we're going to take the USB 3 or the USB connectors, the power supply connectors, everything, and we're going down with it, and it's going to be running underneath the chassis. Now, if we're using this wire mesh, the cables can actually just go right through the mesh, and then to make it look pretty, we can actually take fiberglass and just sort of run it around there, and what you'll have is just a cable that kind of pops out of the glass. Power supply is right over there. It's a big honking monster. It's 1,000 watts. I don't need 1,000 watts. Technically, if we're using 38 drives, they're 900 milliamps a piece, which is about 4.5 watts at max load, which they're only really pulling when they're spinning up. Realistically, they're only going to pull 2.25, maybe 300. But even at max load, that's only a little over 200 watts. So we have more than enough power. The thing is I was pulling it all, essentially, these are all going to be powered, other than the 10 that are on the board, well, I guess the 14 that are on the board, these are all going to be powered from the PCIe cards, which I'll get to in a minute. And those are going to be powered by the Molex connectors. So, which means we're essentially pulling 200 watts from the 12-volt rail, which is a hard, the 12-volt V1 rail, which is a hard ask on cheaper power supplies, because they don't tend to put a whole lot of power there. They mostly the way those rails are set up is they're set up for the PCI Express, or for the video card, or the PCIe, the video cards, or the 8 pins, the things that normally pull power. Molex is nothing. So, but I wanted to make sure that it was equipped, and the way this particular power supply is set up is that the PCIe's and the 12-volt V1 are on the same rail, which means I can pull up to 1,000 watts off of the V1 rail, which obviously we're not going to do, but you don't want to burn out a power supply. So, like I said, essentially what we're doing is we're doing a box. There'll be we're going to get a custom piece of bronze glass to go over the top of it. It'll be about 1.5 inches. for the glass standoffs over the top of the case. There'll be open air for about 2 inches. Then these go down about 6. Then you have the wire mesh. And then you have another about 2 inches underneath that, which actually isn't used for anything. It's just so that nothing's overhanging underneath the case. I know you heard me mention that I'm doing this in wood. I'm doing it in wood because it's the I'll call it the most strategic option. I'm obviously not going to leave it in wood because that would be ugly. What I've done is ordered some really high-end leather, and I'm wrapping all these pieces. Every inch of wood is going to be leather wrapped, which in itself costs a fortune. But what you're ultimately left with is a really nice high-end looking case that ultimately is made out of wood. Now, we're not using particle board or anything stupid like that, but it's wood, so you need to make it look pretty and all that fun stuff. Okay, so that's pretty much the basics here. Now, you may be wondering how I'm going to get 38 USB connectors connected to the system. Now, obviously, what I can't do is just get some USB hubs and connect them up. I mean, you could, but you'd completely flood the controller. I mean, it would be less than useless. Even at USB 3, you're just going to destroy the system. So what we have to do is I bought what I bought. You'll also notice that the motherboard is not in this pile of stuff, and that is mainly because I just couldn't get one. It's on a 2-week back order. So I will have it shortly. It'll give me enough time to do some leather wrapping and do some rewiring of the cables and sleeving and all that fun stuff before it gets here. But it's the X99-EWS from Asus. Asus has just been the top quality boards lately. And this is the WS means it's one of their workstation boards, which is kind of their top tier, just sort of commercial strength. You can think of it that way. So the way this one is set up, it actually has 10 USB 3 connectors as part of as part of just the regular connectors on the side of the board. Then you have another on the right hand side here. You would have another 2 USB 3 headers, which will power another 2 ports apiece. And then that's only 14, and we've got 38. So then we got to get into the expensive stuff. That is these over here. I'll go ahead and take these down. What you have are these, which are the StarTech PCIe USB 3 cards with the they're 4-port cards, but the reason that these are so expensive is because you have 4 dedicated controllers on card. You can very easily buy a USB 3 PCIe card that'll work in a 1X lane that for about $20. But they all use the same controller, so they're all sharing the 5 gigabits bandwidth. And because we're essentially making one giant cluster from all these drives, there's going to be a lot of I/O traffic and just background overhead that I can't flood the controller that bad, because it once you start getting to all 30 of these, I mean, your bandwidth is just going to be nothing. Even at 5 gigabits, it's going to be nothing. So we need separate controllers. So this particular board, the X99EWS, has 7 PCI Express lanes, and this is one of those wonderful new boards, obviously based off of the X99 chipset, that actually will support X16 across 4 lanes, 4 independent lanes, 4 actual X16 lanes. Or in the particular configuration I'm going to run it, is that it'll take, at worst, the way it boils down is, at worst, you would still have no less than X8 across all of them, which is a big ask. And it's also why this board is over $550, is because of the separate controllers they need to be able to do this, because the board will allow you to do that even if you didn't buy a processor that has all 40 lanes. Some of the new processors only have the 28 lanes, and it's sort of a technical voodoo in order to get it to do that. And it's just an expensive set of microprocessors in order to get it to handle that data. I did this. We are going the Xeon route in this system, so I do have all 40 lanes. I did make sure and go that way, but in this setup we have 7 full PCI Express lanes. What we're gonna do is run one video card out the front here. That's this guy. And the reason we bought this guy, why we paid $80 for a video card for no apparent reason, is because it's a tiny card, and it's very easily cooled and keeps itself happy. It doesn't look atrocious. It doesn't have giant fans and heat sinks and all that crazy crap on it. And because this essentially becomes a media center and a server for this client. So he just needs to be able to take HDMI and go out to his receiver or TV. And there are cheaper options to do that, some older class of cards. But I just didn't want to go 6 years old on a card. I don't care if they still make it. It's just a little too cheap for something this high end. So this is a wonderful little card. I don't know if it has an actual picture. Yeah, there's kind of a picture on the back of it there. It just has a nice little heat sink on it, and it's ultra low form factor, doesn't take up any space, because I've got 6 of those that come after it. Now, these are going to run you about $130 a piece, which again is drastically more than the $20 that they're going to charge you for a generic one that you can get anywhere. But that is because you'll notice it's also a full-length card, and it needs an 8X lane. Actually, I think it'll go down to an X4 lane. I'm not sure about that. Oh, and of course, the USAP is going to be a big deal here as well, being able to have it used to do the serial bandwidth. So unfortunately, those are about another $130 a piece. So you got another $700 there. Excuse me, my brain's running around. So again, so essentially what you're looking at is 6 PCIe controllers, 10 on the card. Well, you've got 24 ports here, 34, and another 4 here. And this is without me using any hubs or so this is everything is direct to the board that we're connecting up here. Then of course we're just going to have this massive array, and of course this is and we mentioned this before, I'm considering this a Rube Goldberg build because this is absolutely bonkers. There's no logical reason to do this. You can very easily buy SATA hard drives for 6 terabytes, 8 terabytes, and plug it up to your SATA connector and be done. It's a 5-minute fix. This is an asinine, way out of left field way of doing it. I'm not aware of anybody trying to go this ridiculous with it. I know of a couple of situations where people have hooked up some, 10 bay or a couple 10 bay connectors or hubs and running some hard drives externally. But I'm not aware of anybody actually trying to build a NAS over USB directly in a system. So this, maybe somebody's as crazy as me. It'll be fun. It'll be crazy. Of course, in order for this to actually work, we have to use Windows 8 or above because they use storage spaces, which will allow us to cluster this all into one piece without using RAID. So this is going to be one giant array, somewhere around 16 terabytes. I'm not sure how much we lose with parity just yet, but we're going to be somewhere around 16 terabytes. And also to just kind of catch everybody, because I feel like I kind of glossed over it. So the drives that I got, all these drives that I got in the set from this auction actually turned out to be way better than I thought. So, we were at I don't remember what I said, $350, something like that for the auction. And most of these, so I have these marked on the front here. What's inside those circle is the total usage hours on the actual drives. So you notice this guy that I actually pulled out of this closure, he had 15 hours on this drive. So that means that drive had only been used a total of 15 hours. Now, every single drive that I got in this auction worked, which blows my mind a little bit. I had a couple of dead controllers, you can see in there. But 3 out of 50 or 45, whatever I ended up with, isn't that bad at all. And out of all of them, this stack here are the only ones that I considered high volume usage. 1,000 hours, 1,500 hours, 3,300 hours, 900, another 900. I mean, that's 5 drives that I consider having actual usage. Everything else is either brand new or really damn close to it. I mean, if we look through the stack, I think this is 80% of everything has been almost new. So I'm not entirely sure why they were selling them off or what the story that goes along with that. But this worked out really, really well. So essentially we have, for about $350, I got 45 drives that all retail for about $60 a piece. And they all work and everything's gravy. So we're able to take some of that money and shove it in other directions. But even still, this build will be ridiculously expensive. So anyway, looks like I'm just over 20 minutes, so I'm going to stop rambling. I believe that gives you guys an overview, a real brief understanding of everything that's going along. And I'm going to do some real quick follow-up videos as the process progresses. You know, once the chassis is built, and then once things start going in, once sleeving's done, real quick videos to kind of catch everybody along. And then hopefully you'll see this all together well, by the time you watch this, because the person who needs this needs it by the holiday, and let's not spoil the surprise, I can't actually post this public until the holidays. So by the time you see this, all the videos will be up, so everything will be done. But anywho, watch the videos and give me a shout with any questions, comments, concerns. All right. Get modding.